Okay, we move over to fractions in indices. We've treated our multiplication in indices, division in indices, and product or power law in indices. If you have not watched it, go back to my previous videos and watch them. Now we are over to fraction in indices. We just go over to simplifying the following: 27 raised to power 1 over 3, square root of 1 whole number 9 over 16, and 125 raised to power 1 over 3 times 49 raised to power minus 1 over 2 times 10 raised to power 0. Before I proceed into solving this, before we go on, we must know that in indices, these things are equivalent to these in fraction. Square root is equivalent to 1 over 2, power 1 over 2, raised to power 1 over 2. That is what square root is. Cube root is equivalent raised to power 1 over 3. Remember, it's not equal, raised to the power of 1 over 3. Fourth root is the same thing as raised to power 1 over 4. Did you get it? So the same way, 2 root 3 is equal to raised to the power 3 over 2. 4 root 7 is equal to raised to the power of 7 over 4. All these things are raised to the power. They are all raised to power. So let's solve for example number 1. Example 1, we have 27 raised to the power 1 over 3. 27 raised to the power 1 over 3. I will teach this using this simplest method. You see the same thing with maybe what you know, but this is the simplest way. I advise we solve it. 27 could be raised to another powers. That is 27. That is to say that 27 means 3 raised to power 3. 27 is equivalent to 3 raised to power 3. That is, let's check, 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is what? 27. So we can replace 27 with 3 raised to power 3. So 27 is now 3 raised to power 3. Remember, we still have our power as 1 over 3. 1 over 3. So therefore, this has entered into our product or power law. But let's not just make mistakes. 3 raised to power 3 is still 27. 3 raised to power 3, and bracket means times. Remember, we were multiplying times 1 over 3. So for us to solve this, simple. This can cancel this out. When this cancels this out, you have your answer as the only thing remaining is 3 raised to power 1, which is equal to 3. If you want to test, press in your calculator cube root of 27, it will still give you 3. That is how we got it. Now, without wasting much of our time, the second example is square root of 1 whole number 9 over 16. If you are given something like this, to solve, first of all, change the mixed fraction to improper fraction. That is to say, we are having 16 times 1 is 16, and 16 plus 9 is 25. I'm changing it to mixed fraction. 25. Now, how do we solve this? Remember, I told us that square root is equivalent to raised to power 1 over 2. Cube root is equivalent to raised to power 1 over 3. So since this is square root of 25 over 16, it is equivalent to what? 25 over 16, all raised to the power 1 over 2. Do you understand? Then to solve this, remember I told us since this is inside the bracket, the two of them are sharing the power. Since they are in the bracket, the two of them owns the power. That is to say, 25 is raised to power 1 over 2. Divided by 16 is still raised to power 1 over 2. To solve it again, 25 in index form is 5 raised to power 2. Remember, it's still have raised to power 1 over 2 outside. And 16 is in index form. Is, you can say 2 raised to power, you can say 4 raised to power 2. Let's check. You can say 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Or you say 4 times 4, 16. So it's either you use this, but I advise you use the lowest term. That is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. That's 2 raised to power 1, 2, 3, and 4. 2 raised to power 4. 16 is equivalent to 2 raised to power 4, all bracket, raised to power 1 over 2. To solve this again, we have 5 raised to power 2. Remember, 1 over 2 is times 1 over 2, all over 2 raised to power 4 times 1 over 2. Something can be divisible. 2 cancel 2, we have 1. 2 cancel 1, 2 cancel 4, we have 2. So the remaining answer here is 5 raised to power 1 times 1 is 1. We have 5 raised to power 1 over 2 times 1 is 2. 2 raised to power 2. That is what we got. 5 raised to power 1 and 2 raised to power 2. Let me write it out here. 5 raised to power 1 divided by 2 raised to power 2. So therefore, it's equal to 5 over 2 raised to power 2 is what? 4. That is your answer. Now, moving over to the third one, check it out. If you have any question, you can drop your questions in the comment section. Check it out. Drop your questions in the comment section while I wipe it. Now, solving the third one, which says 125 raised to power 1 over 3 times 49 raised to power 1 minus 1 over 2, then times 10 raised to power 0. Get this well. We have 125 raised to power 1 over 3 times 49 raised to power minus 1 over 2 times 10 raised to power 0. To solve this, remember, this is cube root, but since it's already in this form, we'll check what it is. For 125, you will check what is the index of 125. The index of 125 is 5 raised to power 3. That is to say 5 times 5 times 5. 5 raised to power 3. 5 raised to power 3 brackets 1 over 3 times 49. The index of 49 is 7 raised to power 2. Right? 7 raised to power 2 brackets minus 1 over 2 times, let's still leave this. Let's still leave it for now. So here, to solve it, we still write it out. 5 raised to power 3 times 1 over 3 times 7 raised to the power of 2. But remember, I told us that our minus sign, raised to the power of minus sign, simply means 1 over. 1 over. I'll still come over to that one, whereby you have minus 2 over 3. It will no more be 1 over. It will be 2 over, then the down 1. I'll still come over to that. But for this, since it is minus 1 over 2, it's still 1 over, then 7 raised to power 2. Remember, we have our 2 times 2. Multiplied by 10 raised to power 1 is 10 raised to power 0. Remember, I told us everything raised to power 0 is what? 1. So let's divide. 3 cancel 3. Is there anything cancelling here? No, I don't think so. So we have 5 raised to the power 1 times 1 over 2 times 2 is 4. 7 raised to power 4 times 1. 5 raised to power 1 is 5. 7 raised to the power 4